Okay, so only one question we're going to review for 10.5.2. There were lots of questions, but it is a starred section, so they're all kind of pretty spicy. 10.5.3 isn't bad at all, so hopefully with the solution manual you can figure that out. 10.5.6 is a little spicy, but again with the solution manual and understanding what directly proportional is, I think it's figure-outable. We're just going to take a look at this one just to give you something. So the reason I want to talk about this is because it wasn't just people said, I don't know what to do, right? A lot of them, they said they don't know what to do. But this one, I saw people doing something that's good, which was, let's get rid of this root. Let's square both sides. Now, the problem, and this is why I want to address this, is that when they squared it, they told me that this gets you x plus 1, which is beautiful. It totally does, right? Those squares and those roots go away. They're inverse operations, totally fine. But then they said this becomes 1 squared, which is 1, and then minus x squared. But that's not what happens here, right? This means times it by itself. And so what you end up with is this. They're missing a middle term, right? So that's what this means. Just to be clear about why this works. When you square something, it means times it by itself, right? So we get root of x plus 1 times the root of x plus 1. And that'll equal 1 minus x times 1 minus x. When we do this, since they're both square roots, we end up with this. Both inside the square root. And so what we end up with here then becomes this. So I'm gonna do the right side first. I guess I'll just do it on this piece of paper. 1 times 1 gets you 1 squared, which is 1. Totally fine, right? Just as a lot of people are saying, this gets you 1. But then they missed that you're also going to have some middle terms, a linear term, right? We get 1 times negative x, which is negative x, and we get another one of them, which shouldn't surprise you because we're timesing it by itself. We're going to get the same thing twice in the middle. And then lastly, you get that positive x squared that people were seeing. So if I rewrite this nice and pretty, it's going to be x squared minus 2x's plus 1. Again, keeping it on the same side of the equation. That's an x squared. That's minus 2x's. That's plus 1. Now over here what you get, and I guess I'll keep doing it in purple, is you get this. Of course, if you take something and square it, and then square root it, you get back the original. So this just becomes x plus 1. And that's what we were saying earlier on this other page, right? That just becomes, after you square it, x plus 1. And here's why. So now, if we get our equation to equal 0 by subtracting x and subtracting 1, we get this. Because of course subtracting x gets us negative 3x, subtracting 1 gets us 1. And this you might be able to solve in your head. A lot of people try to divide everything by x. Not a good idea. You're getting rid of one of your answers. Instead of dividing, always factor. They have a common factor of x, right? Take out an x from both. And you're left with this. And again, because this one's so easy and it's so different than what we're used to, people get thrown off here. So this could be a basic question that I would have asked on like an earlier section. And it's that they both have an x, so we factor it out. And what's left over is x minus 3. So our two answers are 0 or positive 3. Now, it's important to go back and check that these answers do actually work in the original problem, because we did get rid of a root here. And sometimes that can provide extraneous answers. So 0 and 3 are what we're saying. Let's go back and check it with the original problem. The original problem, of course, was this without the purple. So if I have this, something for x and something for x, and we say 0, does that actually work? We'll try 3 next. Well, we end up with the square root of 1 equals 1, which of course is true. So totally fine. Our other option was 3 for x. Let's check that. And this is 3 plus 1, which is 4. So we get the root of 4 equals negative 2. And that is not true. You might say, well, wait a minute. If I root 4, I can get a positive or a negative answer. This is true. When we, as the humans behind this stuff, root 4, we need to consider both possibilities because we put that root there. But because someone else already put this root here, again, without the purple, they want the positive version of this root. If they wanted the negative, they put a minus sign in the front. So the positive version of root 4, that's what they're giving us, right? If they wanted a minus, or the negative, they put a minus in front. The positive version of root 4 is not 2. So 3 does not actually work. We have one solution. X can only be 0. And that's an interesting thing. So again, it's kind of weird, and I know this was hard for me to wrap my head around at first. When my teachers told me about this in high school, they didn't really explain it. They just said, hey, if they give you a root, then you don't need to think about plus or minus. What I'm saying is, if they wanted this to be the negative version of a root, right? Like if they gave you this, root 4, if they wanted negative 2 to be the answer, they would have put a minus sign in front of here. They didn't put a minus sign because they want the positive version of this. So of course the positive version of root 4 does not equal negative 2. So no go. 3 is not a solution, only 0 is. And with more experience with that, I think it'll make more sense. So that's all we're doing for section 5.